In this video, I'm going to carry on right from where we left off in the last Waypoint video. I just want to note I did lose the project, so I recreated it watching the previous video. So everything should be the same, but it might just look a tiny bit different on here, and that's why if you notice that. So what I'm going to do in this video is I want to add a few features that were requests on the previous video in the comments. So the main thing I want to add here is we're going to make our agent or the player, whatever you want to call it, that's moving on the path rotate smoothly towards the target. So every time it hits a waypoint, it's going to smoothly turn to the next one, and we're going to control how fast it can rotate. The next thing we're going to add is a way for our agent or player to move forward and backwards. So it's not restricted to one direction. And then based on that, we're also going to add an option where we can make the waypoint system loop or not loop. So when it's not in loop mode, if the player is moving forward, once he reaches the last waypoint, he'll stop at it. And if he's moving backwards, once he reaches the first waypoint, he's going to stop there and not move on. And as well as that, what we're going to start doing is planning to make this a more advanced or intermediate type of system. So we're going to start refactoring the code in a way that's going to make it easier to add features going forward. And we're just going to do some cleanup in the inspector so it's easier to change the settings. Now, before we start doing the actual coding here, I'm just going to explain a bit of what we're going to plan with this. I'm going to look into making a few more videos on this where we can make this a more complex system. So we're going to start moving in that direction. And what I mean by that is we're going to structure our agent, or our player in this case, and our waypoint system to be separate from each other. So for this current video, most of the changes we make are going to be on the waypoint system itself, not the player or the agent. And this might seem a bit strange of why we're going to control the movement on the path instead of the player, but you'll see why that is once we start progressing. To make it a little bit more clear, I'm going to try to describe it like a street system in a city. So what we want to do here is we want to have rules on our streets, and we're going to treat our waypoints as the streets. So you can think if you're driving or walking around your city, each road has different rules. Either it's a one-way street, a two-way street, you can turn left, you can't turn left, things like that. All of those rules are going to be put in place on our waypoint system. What we're going to do with our code is mimic that type of system, but instead of allowing the person or the car driving the streets to make decisions, for now we want to keep it simple. So we're not going to make any decisions on the player, the thing that's moving. All we're going to do is follow the road and obey the traffic laws. And then as we progress on making this system better, we're going to start adding in logic onto the player. All right, that's been enough talk. Let's get into this. So let's start with our waypoint script. And one thing to mention, with the new logic I explained of how we're going to progress on this, it might make sense to rename this script. Instead of waypoints, we might want to call it path or something similar to path. I'm going to leave it as is for now, but in a future video, I'm probably going to change that. Okay, so the order we make these changes in doesn't really matter. I'm just going to start off with making our player or our agent. And when I say agent, that's just a common term for something that works on a system like this. So when you think of any kind of navigation system, the object that's moving around is called an agent. So I'm going to start on the mover script, which this is going to be our agent, the thing that's actually moving. And right now what we do is every time we get a new waypoint, we set the transform.lookat here to point towards the current waypoint. So let's make this a bit better. We'll start making some variables here. Now the actual math behind this, I'm not going to go into full explanation because quaternions are quite complex, and to be honest, I don't fully understand them myself. This is very common practice in code that you use for rotations. You can do any Google searching and you're going to find these similar results. So I'll be honest, I don't fully understand the math behind them, but the logic is pretty simple, and I'll try to explain it the best I can here. So the first thing we need is we're going to need a variable to store the rotation we want in it. Now I'm going to put comments on as much as I can here so we explain everything. So I'm going to put the rotation target for the current frame. And I'll explain this a bit more right away here. So I'm going to make a private variable of type quaternion. And if you're not familiar with quaternions, They're very similar to something like a transform, but they store a rotation. There's multiple different values of a rotation, and they're all stored in here. And I'm going to call this rotation goal. So what this is, every frame, this is the end goal rotation that we want to get to. So this is basically going to be the rotation that the agent needs to face our waypoint. So in simple terms, all we're saying here is this rotation goal is the rotation our player faces the waypoint. Okay, and then the next thing we need here is we're going to need to store the direction to the waypoint. So I'll put the direction to the next waypoint that the agent needs to rotate towards. Okay, I'm going to make this one just a private vector3. And I'm just going to call it direction to waypoint. Okay, so that's all the variables we need. So if we go down here, this is the start. When we start our game, automatically it's going to look to the first waypoint. So this one I'm fine leaving as is. We don't need to slowly rotate. When the game starts, I instantly want my player, or the agent in this case that we're calling it, to be looking at the first waypoint it needs to move towards. So that one snapping instantly is fine. So what I'm going to do is in update, this one here, we don't want to instantly snap to the next target. And like I've said in most videos, I don't like deleting code until I know the new code works. So I'm just going to comment out this line. And below here, I'm going to make a new method. I'll just put a comment too. So I'll put, will slowly rotate the agent towards the current waypoint it is moving towards. Okay, I'm just going to call this rotate towards waypoint. And now in here, what we want to do is this direction to waypoint. We need to get the direction. So if you're not familiar with how to get a direction, all you need to do is take the direction of the target you're going to, which is the current waypoint dot position, and subtract your current position. So this right here is going to take the current waypoint's position, and it's going to subtract our position. And this will actually give you the direction. Doing this does give you a longer vector3. All we want is the direction, not a length. So we can just do dot normalized. Okay, and if you're not familiar with how normalized works, just leave a comment below. I don't currently have any videos explaining normalized. There are lots of great ones out there. I believe Brackeys has a great one. But if you do want a simple explanation of how that works, leave a comment below and I'll happily make that video as well. Okay, so next we need to take our rotation goal. As I mentioned, this needs to be the rotation that the player needs to face the target. So what we can do, just like we did the transform.lookAt, Quaternion has a lot of different methods built in as well. So there's one called quaternion.lookRotation. And this works almost the same way here. So instead of the current waypoint, we need to put in a direction. And we already have our direction. We just got to put in direction to waypoint. Now this is the rotation we need to face this target. But again, we don't want to instantly snap to it. If we set this as the rotation, we're just going to do the exact same thing we did here. We're going to snap to it in one frame. So what we need to do is set our transform.rotation equal to quaternion.slurp. This works the same way as lerp if you're familiar with that, except it does it spherically. So it does a full rotation. And if you're not familiar with lerp, the quick summary is basically you're going to move between two positions, but very slowly. You're only going to take a percentage of it. So again, like I mentioned, a lot of this math stuff is stuff that if you want to learn how it actually works, leave a comment below. I can do my best to make some videos, but it does get pretty math heavy. So a lot of that stuff, when you're starting out, a lot of the time you don't necessarily need to know how it works behind the scenes. You just kind of have to learn how it works to use it, and then you learn it as you go. But in this video, it's way beyond the scope of this video to go into the details. Okay, so to pass in here, we need to put in our transform.rotation. So this is our current rotation. Now we want our rotation goal. So that's our end rotation. And then in here, this is the speed we want to rotate it by. So we haven't created this yet, so I'm going to make one right away. Just call it rotate speed. And then we want to multiply it by time.delta time. So let's go make this variable. And I'm just going to put it up somewhere here by the move speed. So I'm going to serialize this one so we can change it in the inspector, private float, call it rotate speed. And I'm just going to set this to be maybe something like, I'm not even sure. I'm going to set it to 4. We'll try that out. We'll see how it works. So now all of our code here is set, but we haven't called this method yet. So what I want to do is, we don't want to call it right in here when we get the waypoint, because that's only going to call it once, never again, until we get the next waypoint. We need to do this every frame. So we want to call it right here in update. And if you look, this isn't in any if statement. It's right in update. So now this is going to happen every frame. So let's go to our game and make sure this works. Okay, there we are. We're rotating. So I could probably do it a little bit faster. If we select our player and we look on him, so now he has a rotate speed. So we can try increasing this. There we go. That's looking a lot better. So maybe like 10. Okay, we'll go with 10. Remember, I didn't save that in play mode, so I just got to set it again. So I'll set it as 10. And now, as I talked about it actually, let's do this right now, since we want to start making this into more of a system where other people can use it in your game. So we want to start describing stuff in the inspector. We don't have to go into the code for everything. And same with sometimes you have a game designer or a friend helping make your game that doesn't know how to program. We want to make it so that they can use these systems without going into the code. So the first thing to do that for rotate speed here, what I'm going to do is above it, I'm going to use an attribute called range. And we can set the range we want to use for it. So I'm going to set the minimum. So you can see here to use range, we set a minimum and a max. So I'm going to set 0 as the minimum, and then I'll set, say, 15 as the max. And then maybe I'll even put a comment here. You know, we can put how fast the agent will rotate once it reaches its waypoint. So we can put that, and now we have a comment explaining it. On our player, if we look now, rotate speed, notice it has this slider. So you can still set a manual value, but if we slide, it goes between our minimum and maximum. So this makes it a lot easier for somebody working on designing the game to not have to manually enter everything. And then you can kind of set the minimum and max of where you think the value should be, so they stay within that range for you. So something like rotate speed, we don't want to allow somebody to set it to 50. We want to set a range so they know any value within this slide bar is okay. Now the one thing to note, if you try to type in a value outside, say I try to type in 50 like this, it's going to go to the maximum. Now one thing to be clear on with this though, this is just setting it in the inspector. So if you make code changes that are going to keep increasing the rotation speed, that will go outside of this range. This only impacts the inspector. And as we run the game, we can see the difference. So if we go very slow when it hits a waypoint, it's going to rotate very slowly. If we crank it up, it's going to turn a lot faster. There we go. Okay, and now let's start adding a loop option. So if we go back to our scripts here, let's go to waypoints. And currently we're drawing lines between all of the waypoints. So we're going to want to set an option that makes us able to loop or not loop. Let's make a serialized private variable. I'm going to make this of type bool. And I'm just going to call this can loop. And I'm going to set it to true by default. Okay, and just so we're clear on everything, let's document it so if anybody reads, they know what this is. So sets the path to be looped. So agent will go from last waypoint to the first or vice versa. Okay, and as we start adding more settings, it might get our inspector a little cluttered. So I'm just going to add a header here. And I'm just going to call this path settings. That way they're kind of grouped together. So if you're not familiar with what a header is, all it does is make a little header text field in the inspector. So if we look on our Waypoint script here, see now it says path settings. There's a little gap here, and then it starts showing the settings. So this is a way we can start cleaning the inspector to make it a bit easier to read and work with here. Okay, so we have a loop variable, but it doesn't do anything yet. Looking in the game, the first thing I want to do is, if this is set to loop, this is fine. But if we have this unchecked, there shouldn't be a line between the last waypoints here. So if we look at it here, we see between all of them. So let's change that first. And this is very easy. If you remember from our code in the last video. So here we're looping through each waypoint. And then at the very end, we draw between the first waypoint and the last waypoint. So all we have to do is just do a check here. So we can just say if the path is set to loop, then draw a line between the last and first waypoint. Okay, and we just need an if statement here. All we have to do is say if can loop. So if it's true, we want to draw this. And otherwise, we do nothing. So it's really that simple. If we go back, see, now it's unchecked, so it's gone. If we check it, it's right back. So this does nothing in our game. This is just for our visualization. But this is going to make it a lot easier if you start making very complicated paths, so you can actually see what's happening here. And later as we do things, how I mentioned with the street system, if we start changing some of these little lines to be, say, a one-way street, we could make them a different color than the other lines. So it's very easy to look at our path system and know exactly what's going to happen on those lines. So now we need to go to our next waypoint method here. And while I'm here, I'm just going to add a comment too, just to keep this clean and understandable. So I'm just going to put, we'll get the correct next waypoint based on the direction currently traveling. And we haven't put that code in place yet, but we're gonna. Currently, our agent can only move in one direction forward. So that's going to make it a bit easier to start with here. All we have to do is check if we're at the last waypoint. So all we're saying here currently is check the current waypoint if its index is less than all of the children, which basically means it's not the last waypoint. Then we want to return this waypoint plus 1 to get the next one. And if it is the last one, then we want to return the first one. Well, now instead of just returning the first one, we have to do a check. So the first check we can do in here is we can just do if can loop, which means the path does allow us to loop. Then we want to return the first one. So that code works exactly as before. But then else, we want to return the same one. So there is different ways we could handle this right now. Basically, what we want our waypoint mover script to do is to stop moving if this is the last waypoint. The easiest way to do it right now is just to return the current waypoint again. So then that means this mover is already at its destination. Later on in this series, we're gonna implement something different where it's a lot more efficient than that. But for right now, that's a very logical way to make this work perfectly, and it's not going to impact your game by any means. So all we have to do is let's just copy this line and just add our bracket. So all this is going to do is get the child that's at the current waypoint's number, which is where we are already. It's just going to say, here's the same waypoint. And since you're already there, it's not going to move. So let's go and test this out. I hope that logic makes sense to you. If there's any questions, just leave comments below, but I think it should be pretty clear and straightforward as we go through here. So let's leave this on looping. Let's run the game. Let's just go to our scene so we see the waypoints. So this is the last one, this is the first. So right now we go across it. Okay, and then if we uncheck it, now when he hits this waypoint, he should stop. Okay, and there we are. So now if we check it, he's going to carry on just like before. Now we have the first step working. We stop when we reach the end. So the next logical step I think in this is to make the agent or the player to be able to go backwards as well. Okay, so in the waypoint script again, And as I mentioned, the reason we're doing this on the waypoints or the path instead of the mover being able to move forward is this is controlling the street logic. So whether the streets are one-way, two-way, things like that. We're not working at the player level at all yet. What's going to happen later is both the path and the player are going to have logic, and we're going to need to make sure they work together. So basically we'll do things like the player wants to move backwards. It's going to check the path and see if that's allowed or not. So if it's not allowed, the player can't go backwards. For example, a one-way street or turning right on an intersection if there's no right turns allowed. That's the logic we're going to try to mimic. So for the current time, let's go back to our path settings here. I'm going to make another variable here. I'll just put a description. I'm just going to put sets the agent to move forward or backwards. Okay, and then we're going to make another serialized field private bool variable. I'm going to call it is moving forward. And we'll set that to true by default. Now this is where our logic gets a bit tricky because we have to start doing different types of checks based on whether we're moving forward or backwards on this path. So it's not going to be so easy as this. So we're going to need to clean up this code a little to be able to do that. So what I'm going to want to do here, to make this a bit easier, every time we do a check, we don't want to have to start doing current waypoint.getsiblingindex and then doing a check on it. Not only is that going to be less efficient because it has to do that search every time, but the readability of the code starts getting very confusing. If we look here already, we see how many, current waypoint.getsiblingindex. Just in this little section alone, we have it 3 times already. Then we're adding a 1. We can easily make that a bit more readable by making a variable to store that in. So let's do this. Let's do variable. We're going to put stores the index of the current waypoint. Okay, and then we just want to do an integer. We'll call it current index. And I'm going to make it equal current waypoint dot get sibling index. There, so already, everywhere that we have that, we can already just replace this with current index. And you can do that with the built-in refactoring methods built into Visual Studio or any other IDE. I'm just doing it manually here. There's only 3 of them, so it's not a big deal. Okay, so code's a little bit cleaner, does absolutely nothing different as of yet, but it looks a lot easier to read. Now doing that same logic, let's make another variable here. And I'm just going to do stores the index of the next waypoint to travel towards. So instead of constantly doing these different changes and putting like current index +1 in these different boxes, let's just make it a variable. So let's do int, I'm going to call it next index. And for the start, oops, that's wrong. We want to do current index. So for the start of this code, we're going to make next index equal the current waypoint, or the current index, but it's going to point to the same one. Now what we can do here, I'm just going to move this code down. So I'm just kind of starting a bit from fresh, and then I'm going to paste that in. So if we start thinking about the logic we need to do with our waypoint system now, ignore this for the meantime, but thinking right from scratch, if we didn't have any of the code and we have to start controlling how this player is going to move, what are the first things we have to check? First thing we have to check, agent is moving forward on the path. So there's going to be 2 options of the direction the player is moving. Either it's going forward or backwards. So we need to check that before we do anything. So let's do if is moving forward. And this is going to be all the code if it's moving forward. So if it's moving forward, the first thing I'm going to want to do is I'm going to want to increase this next index, because the next waypoint it wants to go to is going to be +1 because we're going forward. And we already do that here. So if we look, current index +1, that's what we're doing when we return which child gets called from the last video. So let's do that just in the variable here. Let's do next index +=1. or you could even do next index plus plus. So now we increased what waypoint we're going to, but we have to actually do a check on it now to make sure that's valid. Because if we're already at the last waypoint and we try to add 1, that's going to throw us an error because there's no more waypoints. So you know what, we can even describe that here. Let's do that so it's a little bit clear. And I like doing this a lot in my code too, where I'll do comments explaining what I have to do in the code before I do it. And then a lot of the time that kind of gives your brain a little jog of what you have to code, and it's very straightforward after that. So let's just write it out in plain English. So we need to do, if the next waypoint index is equal to the count of the children, or we could do children slash waypoints, then it is already at the last waypoint. And then what else do we have to do after that? The next thing we would have to do at that point is check if the path is set to loop and return the first waypoint as the current waypoint. Otherwise, we need to subtract 1 from next index, which will return the same waypoint that the agent is currently at. We can even put which will cause it to stop moving since it is already there. So those aren't the best notes. I mean, you can put whatever you want in here, but that was just me thinking out the logic of what we have to do and what order and why we're doing it. So I find it's handy to have this in here. I mean, later you might want to delete this, you might want to keep it. So let's do if next index equals transform.childcount. So that's the first part there to see if it equals the last one. Then we need to check if can loop. And if we can loop and we're at the end, what do we got to do? We got to set the index to 0, which is the first waypoint. And if we can't loop, what we're going to do is take next index and -1. So this might seem a bit confusing or pointless of why we add 1 here and then subtract 1 again here. This is kind of our condition. If we met all the conditions and we don't want to be moving anymore, we want to go back to our next index being our current index. So essentially do nothing. Okay, so that is our moving forward, and we just have to do the same thing with the moving backwards now. So we just need to take this bracket here. Okay, and I'll even put a little code here. Agent is moving backwards on the path. Okay, let's do else. This, you know what, I'm just going to delete this. Let's redo this from scratch. Okay, so this is going to be almost the exact same logic, just the opposite. So first thing, let's do next index minus equal 1. Because we're going backwards, we want to take 1 away. So let's get the waypoint before where we're at. And then again, I'm going to do some notes here. So I'm just going to do if the next index is below 0, then it means that you are already at the first waypoint. Check if the path is set, to loop, and if so, return the last waypoint. So same thing, just the opposite. Otherwise, what do we do here? Yeah, otherwise we're going to add 1 to the next index, which will return the current waypoint that you are already at, which will cause the agent to stop. Since it is already there. Okay, so that's just my straight English wording of what we have to do here. So same thing I said before. So let's do the opposite here. Let's do if next index is less than 0. This means we went below the first waypoint. First thing again, we want to check if we can loop. So if we can loop, our next index is going to be the transform.childcount -1, which means the last waypoint. And otherwise, let's add 1 to it. Because remember, we already subtracted 1 here. We need to add 1 back to make it exactly as it was. Okay, and the only difference now with all of this code is right at the end here. This is where we need to actually return the waypoint because we deleted it out of the old code. So in this case, all we need to do is return transform.getchild next index. Okay, I'll make a little note here too. Let's do return the waypoint that has an index of next index. So if you actually look at the code, there's not much there. It's a lot more compact, a lot cleaner. And this is going to allow us to work towards more advanced systems going forward. So let's test this out before we look at anything else. So now we have 2 settings here, can loop and is moving forward. Let's run our game. Go to the scene view again, just so we can see these. As well, in case you're not aware, on the game tab, there is actually an option here under gizmos. If we click it, we can see gizmos in the game view. So this is not anything that the player will see when they're playing, just for us in developer mode. Okay, so we're looping around. If we uncheck is moving forward, as soon as he hits the waypoint, he's going to turn around. Now notice it's not real time because the only time he's checking is when he hits a waypoint. Again, that's something we'll work on in the future videos and lessons for this, that we can make it more advanced. So backwards is working. Let's test out looping. Okay, so that was the last waypoint. We're going back. All right, so we have nothing here. If we turn on can loop, it goes again. Stop there. If we turn on loop, it goes across. So it looks like all our conditions are working. Okay, so that covers a few of the basic requests I had on the last video to add here. So that gives you a few more options. And like I mentioned, I want to try keeping this video going forward where we keep adding on to this. We make it a full series and we start adding some more cool features to this path system. So if you have any suggestions or features you want to see added on this in future videos, let me know and I'll keep trying to add on to it. Thanks for watching and I'll see you in the next video.